Okay, the chain rule. So we're going to focus on number 2 here, which is the general form of the chain rule. What the chain rule says is if you have a function within a function, you're going to take the derivative of the outer function, leave the inside inside, and then multiply by the derivative of the inside. So let's go through these practice problems. So on the first one here, your outer function is the cubing function. So the derivative of something cubed, bring the 3 down, make it a 2, inside stays inside, multiply by the derivative of the inside, which is 3x squared, and you can leave it like that, or we can multiply these together, 9x squared, x cubed plus 7 quantities squared, and call that my answer right there. All right, number 2, easiest thing to do here. You could use the quotient rule, but what I'm going to do is I'm going to just pull that 5 out as a 1/5 out in front, cosine of 3x. Now here, 3x is my inside function, cosecant is my outside function. So f prime, constant multiple of 1/5 stays as 1/5. Derivative of cosecant is negative cosecant cotangent. The inside stays inside, and I multiply by the derivative of the inside, which is 3. And then if I bring all those numbers to the front, negative 3/5 cosecant 3x cotangent 3x. All right. On number 3, this is a product, so I'm going to use the product rule. I'm going to start by rewriting this 2x minus 3 to the positive 1/2. And now I can go ahead and use my product rule. Do some color coordinating here. We'll call that the first function, and let's see, we'll use yellow to denote the second function. When I work out this derivative, it's going to be first, oh no, ugh, crashed one note. Okay, back, let's go back. See if we can get this back here. All right, one more time. Going to be first, derivative second. Now the derivative of 2x minus 3 to the 1/2 is 1/2 2x minus 3 to the negative 1/2 times the derivative of the inside, which is 2. And then I'm going to add to that the second times the derivative of the first. Back to the color coordinating. This here is all the derivative of the second. This here is the second. And then this is the derivative of the first, and then that is the first. So here's your first derivative second plus second derivative first. All right, once again on x squared sine x, we've got a product. The sine has an inner function to it. So when I do my product rule, I'm going to have to take, in my derivative of my second, I'm going to have to use the chain rule. So here's your first derivative of second. Derivative of sine is cosine. The inside stays inside, multiply by the derivative of the inside. Then I'm going to add to that the second times the derivative of the first, and there's my answer. You could bring the 2 up here and the 2x to the front. The one thing you cannot do is you can't multiply those together because this 2x is inside the sign, that 2x is not. We'll go back over here. Yeah, and I guess over here I forgot to do a little simplifying. We did say no negative exponents, so I'm going to cancel those 2's out. Move the 2x minus 3 down into the denominator with a positive exponent, and then leave it like that. No negative exponents, no fractions within fractions. All right, number 5, equation of a tangent line. We start by taking our derivative, f prime of x. Once again, we have a product, so we have to use the product rule. First derivative, second. 3 comes down, becomes a 2. Inner derivative is -2. And then I have to add to that the second function times the derivative of the first. And now because I want the tangent line, I'm just going to go ahead and plug 1 in here to get the slope of the tangent line. 1 times 3 times, let's see, 1 minus 2 is -1 squared times -2. And then 1 minus 2, -1 cubed. So this is, let's see, -6 minus 1, -7. And then using our point slope form of an equation of a line, plug in the necessary values, minus a -1, slope of -7, and x minus 1, and there is the equation of our tangent line. And then finally, number 6, we've got a table of values. We've got a composition of functions. So h here is defined to be g of f of x. This is not a product, this is a function within a function. So when I find my derivative, I'm going to use the chain rule. And I'd refer you back to number 2 here. I'm doing this exact same thing up here. I've just got the f's and the g's in a reverse order. So outer derivative, inside stays inside, multiply by the inner derivative, and now substitute 4 in. H prime of 4 is g prime of f of 4 times f prime of 4. So that's just substituting 4's in all the way across for all the x's. Now from the table we get the values. So first is f of 4. Here's f, here's 4. There's your f of 4 right there. It's 5. So that's in there. And then f prime of 4 is -1. Now this 5 is inside the g prime function. This is not multiplication, this is inside the function. So now we get g prime of 5 from the table. Here's 5, here's g prime, that's -3. And we multiply that by -1, and the result is